This is part two. We're going to be continuing atmospheric pressure. So just to recap, when you have an empty bottle, the pressure inside the bottle and the pressure outside the bottle are the same. The atmospheric pressure inside and outside is the same, so it doesn't get squashed. But if you take out the air from the bottle, you're taking out also the air atmospheric pressure from the bottle. Now, in this example, the atmospheric pressure outside the bottle is larger than inside the bottle, so what happens is it crushes the bottle. Now you can see this happening when you get an empty bottle and you suck out all the air. When you suck out all the air, you're taking out all the atmospheric pressure from inside the bottle, but the atmospheric pressure outside the bottle is squashing the bottle. Now, this is also why our body is not crushed by the atmosphere. This is because the atmospheric pressure inside our body is equal to the atmospheric pressure outside our body. Otherwise, if it was less inside our body, more pressure would act on us and it would crush us, unfortunately. Now, where else is atmospheric pressure used or seen? When you use a straw, for example, when you suck out all the air from a straw, the atmospheric pressure on the liquid in the glass, which is over here, so the atmospheric pressure is pushing down on the liquid, which forces the liquid up the straw from the outside. So it's forcing the liquid up the straw. Now, for a rubber sucker, when you push the rubber sucker, the atmospheric pressure, the air pressure, sorry, inside is released. So when you push the sucker, the air goes out. The atmospheric pressure from the outside, which is outside the rubber sucker, is pushing against the rubber sucker now, which pushes it into place, and that's why it doesn't fall. Now we measure pressure using a mercury barometer. It's not really. I'm going to explain how it works very briefly. So you have this mercury barometer, and what's happening is the pressure is pushing against the mercury, and the mercury is rising up. And according to how much it rises up or goes down, is how you calculate the atmospheric pressure. Now, why would we use this to calculate the atmospheric pressure? We use it because rain clouds form in areas of lower pressure called depressions. So when you have lower pressure, when this reads a low reading, so when it's like down here, for example, this means that there's probably going to be rain. So that's why we use a mercury barometer. Now, pressure in gas. Now, all you need to know about pressure in gas is that when the temperature is increased, the pressure in a gas is also increased. So when you add the temperature to a gas, the molecules, which are already bouncing around, when you add heat, the molecules start bouncing around even more and they hit each other. And this creates more pressure inside the gas. Now, pressure and volume. When you have a small volume or a low volume, the pressure increases. So as you can see in this example, over here the volume is quite large and the molecules are quite far apart. But if you move over here, the molecules are much more packed together, so the pressure is higher because the molecules are bumping against each other and they're bumping against the platform and they're bumping against the sides, so the pressure increases.